Today we're going to chat a bit about redox reactions. Now we have come across redox reactions before in electrochemistry. Now redox reactions are reactions that contain both oxidation and reduction reactions. Now oxidation reactions refer to reactions that gain oxygen or loses electrons, whereas reduction is the loss of oxygen or the gain of electrons. Now, an easy way to remember this is by remembering oil rig. Now, oil rig stands for oxidation is loss of electrons and reduction is gain of electrons. Now, the gaining or losing of oxygen is an easy way to indicate whether a reaction is oxidized or reduced. But with electrons, it's a bit more difficult. And to understand this concept, we go to the periodic table. Now, each element on the periodic table has an oxidation number. Now, this oxidation number will indicate whether it's being oxidized or reduced, meaning it will indicate whether it's gaining or losing electrons. Now, any uncombined element has an oxidation number of 0. So this is like hydrogen gas, chlorine gas, or zinc. All our group 1 elements have an oxidation number of +1. Now, hydrogen is part of this group, so it will always be +1, except when it bonds with a metal. Then it will have an oxidation number of -1. Like, for example, sodium hydride. All my group 2 elements have an oxidation number of +2. All my group 7 elements have an oxidation of -1. And all my group 6 elements have an oxidation number of -2. Except for oxygen. Oxygen will have an oxidation number of -2, except in peroxide, where it has an oxidation number of -1. And then also in F2O, oxygen will have an oxidation number of +2. The reason for this is because the more electronegative element always get the negative oxidation number. Now my ions, which have different charges, will always have an oxidation number that's equal to the charge. For instance, oxygen, if it's charged, it will be 2-, so the oxidation number is -2. Now, if we think about the sum of a compound, the sum of the oxidation numbers must always equal to 0. Now we have all these transition elements in the middle that do not have oxidation numbers yet. So how do I determine their oxidation number? Now, the transition elements can bond in different ways by forming different charges. Now, the charge of the ion is written as Roman numerals, and this will be equal to the oxidation number as well. Now, a good example is iron oxide. Now, we get iron 2 oxide and iron 3 oxide. Now, these Roman numerals will tell me what's the charge of iron in this example. Now, iron 2 will have iron 2+, and iron 3 is iron 3+. Now, remember, the oxidation number is exactly the same as the charge. So, with iron 2+, my oxidation number is +2. So, the oxygen will have an oxidation of -2. And then iron 3+ has an oxidation number of +3. And the oxygen has an oxidation number of -2. This will also indicate how these elements bind together. So iron 2 oxide will be FeO and iron 3 oxide will be Fe2O3. Another thing that we need to take in consideration is our polyatomic ions. Now, these ions also have an oxidation number equal to their charge. Now, these charges you have to go and study and learn of by heart. Some of them are kind of easy to calculate. Like, for instance, if we look at hydroxide, we know oxygen has a charge of 2- and hydrogen 1+. So if we put them together, I will get a total charge of -1. So my oxidation number would also be -1. Let's look at a few examples of how I can identify an oxidation or a reduction reaction. If we look at silver, silver will form an ion by losing an electron. Now remember oil rig, oxidation is loss of electrons. So because it loses an electron, it's being oxidized. If we look at oxygen, for instance, it will gain 4 electrons to make it 2 oxygen 2 minus. Now, oil rig, reduction is gain. So because it's gaining an electron, it will be a reduction that's occurring. So here we can see that silver goes from 0 to +1. So we can see that it loses an electron because it lost a negative charge, whereas oxygen goes from 0 to -2, meaning that it gained an electron, 2 electrons in fact. So that would be reduction. Here's a good example. If we have iron plus copper sulfate, we will get iron sulfate plus copper. We can then break this reaction up into its ions. So if iron, which will not have a charge because it's standing on its own, copper 2 plus. Now this is because it's bonded to sulfate. Now remember, sulfate will always have a charge and oxidation number of -2. So because copper sulfate is a compound and should add up to 0, copper will have an oxidation number of 2 plus. Plus sulfate, which is 2 minus, gives us iron 2 plus. Iron as well is bonded to sulfate. Sulfate still has a charge and oxidation number of -2, which means that iron will have an oxidation number of +2. Plus sulfate, which is 2 minus, plus copper. This is because copper is an element on its own. Iron will have an oxidation number of 0 because it's an element on its own, whereas iron on the product side has an oxidation number of +2. This means that it loses electrons and will be oxidized. If we look at copper, in the reactants, it has an oxidation number of +2. At the product side, it has an oxidation number of 0. So here it gains electrons, so it's being reduced. Now we can also say that iron is the reducing agent, and this is because it's being oxidized. This means that it reduces other substances. Copper, on the other hand, would be an oxidizing agent, and it's because it's being reduced. So it's oxidizing other substances.